It's the YARM score, which is yet another rationalization for modularity talk. But it's, I'm going to be able to save a lot of slides here from my talk because Brian Chan and Peter Kreens did a lot of the work for me to rationalize what we've done for modularity in Liferay. And what I want to really focus on now, so I'm going to be able to fast forward and really emphasize that what they've talked about isn't an ephemeral thing that's going to happen sometime far in the future when, you know, we all reach enlightenment. It's something that's possible now. We just need to apply a little bit of knowledge to the systems that we already have available to us. So the first part is obviously that we're concerned for modularity, and then really the big problem, once we decide we have modularity, and once we want to build systems, the really, really intense, difficult part is actually the resolution process, putting everything together in a running system. And we've been tied so far to the artifact identity model, which is, as Peter mentioned, in the POM model, the Maven model. You have your POM, you literally specify a relationship to a concrete artifact by identity. And yet, an important part of that is also the fact that there's a repository somewhere where you can get these artifacts from. That's not a little incidental detail. It's critical to be able to resolve anything, to be able to come up with a system. You need to be able to get that stuff. Otherwise, you're always having to curate every single library yourself. But there's limitations, as we've seen, to this model. It doesn't represent the real goal or the real intent of what we're trying to achieve. So if you just step back for a moment and at a high level, ask what a customer is asking you to do. And what they're trying to do is basically, they're giving you a set of requirements. I want to have a website that's going to make $1 million a month. But what do you want to do? You know, that's their high-level goals, really, ultimately. Most people don't really care about the technology. They just want to achieve a goal. The technology is incidental. What does a developer want? A developer wants to be able to deliver those capabilities as efficiently as possible, and they want to make money, and they want to get paid to do it, and they don't want to have headaches, and they want to have a beautiful, work-life balance and all of that stuff, right? You don't want to go crazy trying to maintain a system. You want to deliver valuable pieces of software to your customers. So one of the things that we want to try to move beyond is from the identity model to the requirements model, so that when requirements come to us, we have some higher level way or means of language to take those requirements and turn them into capabilities, or at least resolve them to a set of capabilities and then deliver those. And then comes along OSGi. So OSGi has always been a model based on the requirements capabilities, even though in the beginning it wasn't specified in that particular way. There was a bunch of metadata that was defined, and sometime in around 2005, so Peter, they realized, hey, we've done all this work, and we're repeating the process of doing this work over and over again. And so they modularized the process of adding metadata to the metadata system itself. And they came up with a model. They said, hey, we can replicate, we can create an expression language that replicates what we're trying to do over and over again in a single model. And we won't ever have to create new systems of metadata. We'll just build a general model for this abstraction. So they came up with the requirements and capabilities model. And this is a truly remarkable thing, because it allowed us to make a standard expression that we can use a system to calculate. We can use a tool to calculate and assemble based on a set of these expressions which define the requirements and also define the capabilities, and then use a machine and an algorithm to assemble a working system. So what is the missing element that today inhibits us from really putting this to use? It's the lack of knowledge in the libraries, in the modules that we have. We don't have enough information in the modules at this moment to really, really put this to use. So we need to add this. How do we add this? So there's got to be mechanisms. We need to build mechanisms to add, enrich this metadata. And so this is where I get to cut right to the demo stuff. So if you were to see the slides, this is a project on GitHub, and my slides are also there on GitHub. I'm going to go right to work on showing you some real live code. How many people have done the Spring Boot intro training, the examples? It's very, very simple, right? You go to the website, they say, write down this code, write this annotation, execute this command line operation, and you have a running system. That's a very interesting model. It's very powerful. It's very easy for a developer to consume. You assimilate information in small bite-sized chunks, and then you get a running system, and you're always being productive. This is really interesting. And yet, there are limitations in that system, because fundamentally, they've already reached a limit. At any moment, they're limited. They only have n capabilities inside their system, and they're not necessarily expressed properly. So what they do is they do what all systems of software kind of do today. They give you a distribution. They say, hey, here's 500 things we think you're probably going to end up using. And you write your one class, and yet in the background, you still have all 500 things. This is the same thing you have in your operating system. The operating system is a collection of a whole bunch of things that you might use. A Linux distribution is the same. Spring Boot is the same. When you get your runtime, it comes with 500 things. Liferay is the same. You have a system, it has 60 portlets or 100 portlets or 500 modules or whatnot, and you may use 10%. And yet you still have all these things, because we have to try and pre-calculate all of the things that you might use and try to give you as much value as possible. But we want to turn that model around, because what we want to do, we want a developer to take the requirements that they're given and assemble a system that only has the stuff that is needed at the time. There's a lot of implications for this. It will help you protect against security vulnerabilities, because you don't have accidental bugs in parts of the system that you're not using exposed. It also means you're likely going to generate a smaller runtime than you would normally have, which is great when you're trying to scale systems to a large degree. You're not creating big VMs for nothing with hundreds of things or thousands of things that are never going to be used. So there's multiple reasons why you would want to shrink this down. And this is completely possible today because of the notion of resolving against information that's in a repository. So I'm just going to show you a couple pieces of this real workspace that you can actually download from GitHub and try out today and run these examples. And I'm going to work through a couple of features of this. This is actually a B&D Tools workspace. So if you're not familiar with B&D Tools, it's basically an evolution of some tooling that actually started by Peter Kreens way back in the day that have evolved into Eclipse plugins from some command line tools that are very, very knowledgeable about building OSGi applications. So under the hood, there's some magic happening here to create metadata or to analyze metadata from different modules. And hand-waving across how this is all set up, I just want to go and show you some of the very basic building blocks of the system, which is the ability to create configurations that point at repositories. And it's not really important what's here. I just want you to accept the capability as existing. And for instance, I want to show something fairly interesting, like the ability to create a repository configuration, and I don't know if you can read it, but this is a Liferay configuration pointing at Maven Central that says, get all the Liferay artifacts in Maven Central and index them in an R5 repository. And I don't care that there's a lot or whatever, I just want to see them all because I might use them. So that's a very powerful thing. We didn't have to pre-generate, we just created a whole bunch of OSGi modules, we put them on the Maven Central, and through this configuration, I can generate an index and I can do all kinds of analysis against them, against this repository configuration. And Maven Central is not the only source of knowledge out there. There are lots of other projects that generate OSGi bundles and make them available in different kinds of repositories. So another example here is the Jetty P2 repository. So if any of you are familiar with building Eclipse plugins, or you've been involved in the Eclipse tool chain development process, they use something which was repository format designed for them to do deployment, wide deployment of Eclipse plugins. It's called a P2 repository. And Eclipse Jetty happens to be released in a P2 repository. And in that repository, there's a whole bunch of OSGi metadata in the bundles. And so I want to reuse that. So I've got a bunch of repository configurations here, assembled together from different parts of the world. And I'm going to use a single set of tooling to do analysis on that and assemble of runtime. So what I want to show now, take it for granted that I have all these repositories configured, and I start with my application. Note that I'm not starting with any known, other than my repositories, I'm not starting with a predefined framework. I'm not starting with Spring Boot, I'm not starting with Liferay, I haven't calculated the base platform at all that I'm going to work from. The only thing I've decided is that I'm using the servlet API. That's all I've decided. I know nothing else. I just want to run a servlet. That's all. So that's my first contract. That's my first requirement. I need a servlet API. The next is that I have a component annotation here. So there's another implied requirement that I need declarative services runtime. So in Liferay, we use OSGi, we're using services, and the way that we use that is through this beautiful injection framework native to OSGi called declarative services, and so that's what this is. If you've been to other talks and you see these annotations, that's what this is doing. So this is going to create an instance of the servlet for me in a system that can provide me support for this annotation or for this framework. So very simple. This is the complete set of requirements that I have for my system. And now what I want to do is I want to ask this system to deliver me something that runs. Let me just delete this. So I have a BND run file, which is, again, a BND talk, but that's not the important part. The important part is that I'm telling some system that what I want to do is run the bundle that has the symbolic name servlet example. I just want that thing to run. That's the core bundle. If you were in Peter's talk, he had a slide where he had a whole bunch of bundles and then a beating resolver, a circle in the middle, and it started with one bundle as the single, as the root, and then figure everything out. That's exactly what this is a representation of. So BND Tools happens to have this function built in, which is not only available through BND Tools, but also through command line tools, including through Gradle and through Maven and whatnot, to be able to say, hey, looking at these repositories, generate me a system. Now, when you do this in, let's say, Liferay, you write your servlet, you deploy it to Liferay, all you need is a servlet. What do you have a running system of? It's about 400 megabytes. That might be hard to scale in your system when you don't really use everything else. Spring Boot, when you do this very same example, it's around 45 megabytes. Okay, now, if I click the resolve button here, it's going to do this is the beating heart process that Peter had on his slide. It's calculating and it says, hey, this is the result that you need. This is the result I came up with. And by the way, I didn't find any errors. There was nothing that I couldn't find a solution for. This is the end result. There's options available to you, but I don't really care about those. I just want that system running, and I click Finish. And you may have noted that when I looked at the file, I deleted this chunk of code here, or chunk of text here, but this is the calculated set of bundles that are needed. And when I go back and I click Run OSGi, it's going to start a framework. And if I go to the browser, and I go to, it's going to run my servlet. So this is the rudimentary example, of course. But the important part is that you started with some requirements. You started with a very, very fine-grained set, a very concise piece of code, which is just your requirement. It's just your business logic, and you just want to execute it. Now, here's a very interesting part as well. So I'm going to export this into an executable jar. And I'm going to put it in foo, HTTP example. Okay. Oops. Example. Yeah, okay, so it's example jar. Finish. So example jar, oops, sorry. I don't know if you can see what that is, but the size of example jar is 3.8 megabytes. And this is the complete HTTP runtime necessary to run that. What's really cool? That's just phase one. That's just my basic assumptions about my requirements. But I need a little bit more. I want more to add more stuff. And I say, hey, I have this other requirement. I need to log into this. I need to be able to interact with the system from some diagnostic mechanism. So I want to add some requirement. But it's an ephemeral requirement. It's not literally tied to my application. I want to add a shell interface, for instance. But it's not used in my API. It's anywhere. So there's no mechanism for me to tell, or there's no mechanism for the system to read what's in my brain to say, okay, you want a shell to add a shell to this. But through a very convenient little mechanism, I can write an annotation, and this is becoming OSGi R7 functionality, but it's already capable through BND, is that I can create a custom annotation that I can reuse and give to, let's say, a team of developers so that they don't have to think about it. An ability to imply some requirements in their application. And this basically says, I want Gogo Shell through a requirement and capability. So now, if I say at Gogo Shell, and I stop my runtime, and I go back to my bundle here, and I go resolve again, I'm going to get another solution. This solution is different from the previous solution because it now includes, where is it? Here. 4 more bundles, which is Gogo Shell. I really don't care on the version, I just want to have the shell. And when now I run my application again, let me move this up. When I run OSGi, I'm going to have Gogo Shell here. I can see my bundles, and now I can diagnose my system. I can do my tuning or whatnot. So you really want to be able to express your requirements this way. So what do we need to be able to do this? I needed to add more information because even in the normal world, even though Gogo is already OSGi bundles and it's very useful and everything, in the normal, like in the current state, I have to go and drag those actually into my individually. I have to know the names of the bundles. I have to drag them into my runtime, my set of run requirements and whatnot. But I don't really want to have to do that. I just want to add all this information into the repository, and I just want to use a requirement to say, oh, by the way, add this. So technically, I could say, oh, add caching, add transactions, add any other back-end concern that I can't express directly through my application, but I want it to be there anyways, so please add it on. So what are the mechanisms for me as a developer or as a lead to be able to add this extra information into the repository so I can use it? Well, there's this functionality also developed by B&D, which is called an augment, which when I define my repositories, gives me the ability to say, don't only index the metadata that's in the bundles as they are, but add this extra metadata to them. Because that's going to help me. And now I'm going to build relationships between these bundles that didn't previously exist. So I can modify either, if I was in control of all the libraries in the world, I would just add this metadata to the libraries from the beginning. Like I would fix Gogo Shell, but I'm not the developer of Gogo Shell, so I don't have that. I can send a pull request, but who knows when that's going to get integrated. Some other bundles, like for instance, Felix or the WebSocket API. I'm not going to be able to release a bundle of the WebSocket API. I don't want to replicate it. I don't want to patch it. I want to actually use the binary that was released from the originator, but I need to manipulate it in a slight way so that it makes it easier for our developers, my developers, to reconsume it. So I'm using this augmentation tool that I can share with everyone through a workspace or through a shared configuration that somebody goes and does all this work, and developers don't have to worry about it anymore. It'll just be available to them. And so this is really nice. This is really powerful. So you take this further. This was a servlet example. And what if I want to do WebSockets? So I have a WebSocket endpoint here. And I have a component again. I just have an API. I have my Gogo Shell. I have my run configuration. So starting from scratch again, I'm going to run. I want to resolve. So this is a more rich runtime. It's not just the HTTP server anymore. It has to add also the extra capabilities of being able to serve WebSocket endpoints. And again, because I have a repository, I've augmented these, I have the metadata, I've augmented the metadata that I need on the bundles, I've calculated all the bundles I need to run, and now I can just run this example. Actually, it'll interfere on the TCP port here, so I have to kill that one. But then when I run, I'll have my WebSocket. I don't actually remember what this app looks like. Okay, so I have a WebSocket thing happening, and when I start it, it's printing out the server time. So it's doing something silly, but it's doing what I need. I just wrote my application. I wrote my business logic. I didn't care about a limited platform, a limited framework, a distribution. I just cared that I had access to a bunch of repositories that had the knowledge that I needed in there, exposed through some requirements and capabilities model. I put those requirements into my application. I generate and execute a process, and it calculates a runtime for me. And my runtime is exactly the minimum set of things needed to just run my application. And that's really, really cool. It's really, really powerful. So one day, Liferay is going to have a service.xml file that you're probably mostly familiar with, service builder. And attached to that, you'll have some kind of Gradle command that'll say, generate me a microservice for this service. And it'll do this exact process. It'll say, okay, given this XML, given this service, generate me the runtime that will run this service. Oh, and I happen to need JAX-RS endpoint. Okay, I wrote my JAX-RS class, so now my requirements I need are a service runtime for service builder, a JAX-RS endpoint, calculate the system that's going to run that, put it together, package it, and I'm off to the races. So I hope that I was illustrating that what Peter has talked about, what we've talked about requirements and capabilities, is a very powerful model that we're using in Liferay now, and we're using it more and more all the times. It's the very same model that Shema just used in his talk to decide at runtime or even before runtime what the necessary modules are to produce a running framework. Cool. That's it. Any questions?
So how do you come up with well-known shared capabilities, like whatever, GoGoShell, for example? Because if I deploy my servlet, that means that nobody can deploy that servlet without a GoGoShell, right? Or at least not very easily. And
yeah, I mean, yeah. These are just for convenience. You could actually do this from outside the bundle. So I could write this servlet implementation, and from some other central source of knowledge, some other class that, let's say, will represent the final application as opposed to directly here, then I could assemble my requirements. So I could reuse this from some other application that's defining the final outcome. You know, I don't need to do it necessarily here. I just did it here for illustration or for convenience.
And the capabilities describe a family of technologies most often, not a specific implementation. So how do I come up with a name which others would also share, like whatever, command line or something like that?
Right. So, and hopefully I answer the question the right way. So I think what you're asking is how can you kind of standardize the namespace? So, okay, for requirements and capabilities. So first off, the OSGi specifications already have several namespaces defined for particular technologies that they have specified. So they have a capability requirement already defined, let's say, for OSGi HTTP whiteboard support, which is called just HTTP, OSGi.http. And they have one defined for several others, metatype and declarative services and whatnot. And then building your own, so if you wanted to define your own, let's say for something that you don't control, you'd probably just name it in a namespace that you can control. So you'd, for instance, if I wanted to make sure let's say here, I've defined, and this I just made up, this on the on the Apache Aries JAX-RS CXF common bundle, create where's a requirement, capability here? Oh, there's a capability, yeah. Okay, so here, for instance, for the Google command, I just created a new namespace that I don't think collides with anyone else. And first of all, it wouldn't collide because it's within my own set of repository configurations. So I just said generic dependency. That's the namespace. And then the metadata in the dialect for requirements capabilities to allow me to filter on it and to make that relationship. So I just defined a namespace for myself. But if you, let's say you want to share this with the world, then this namespace might represent an organization or a corporation. You might, com.liferay dependency, blah. And then with some, so there's a very strong namespace capability built into the system. And then ideally what we would do collectively is we would enhance the modules we're using, right, by asking these organizations or projects to add this metadata for us, which is at least what I intend to do with a few that we're using. So, any other questions? Over here.
I was using Liferay Developer Studio to build a service that would make a REST call to Salesforce, and I sort of spent a lot of time trying to understand the dependency management in that, and trying to understand how to bring in those third-party dependencies, and it sounds like having something like a resolver would have been great in that circumstance. Can I do that using Developer Studio, or do I have to use this setup here?
That's a good question for Greg Amerson.
Okay.
But as far as generally reusing libraries which are not OSGi libraries already. So for instance, if let's say you knew that the library for Salesforce integration was already OSGi bundle, you could just create a repository configuration here in your workspace that would index it for you, and then you could do a resolve against it, right?
Okay.
But in the real world, we know that there's a lot of libraries that are not even OSGi. Yeah. They don't have OSGi metadata at all. And in that scenario, there's a couple of approaches you can take where you can either wrap that in an OSGi. So you basically take the original and you wrap it into an OSGi bundle, and there's several different ways that you can do that. So that would be the approach. It would be to enhance the library.
Okay.
Somehow, either through wrapping it or through modifying it.
Thanks.
Another question here?
Okay, so the former Liferay idea before was you tell the client that, look, I have a Liferay installation. Out of the box, it does 90% of what you do. Then you got a hook, an X environment, and some portlets that you can drag and drop, and you got what you want. And now you see a client and you say, like, look, I don't have a box anymore.
No. This is just an add-on. I don't see a future where Liferay Portal and the framework or the distribution of Liferay doesn't exist. Okay. This is an extra set of capabilities that we are going to provide.
It's not that
it's going to be, hey, okay, we deliver a product that has 700 bundles in it.
All right.
But if you only need 30 of them to build the thing that you really want, and we happen to have the technology to give you, then go ahead. Here's a way to do it.
So the idea is not that the next step here would be, this is the document and media.
It could
bundle.
be. It could be, here's a runtime that only has document and media in it.
Yeah.
Yeah, exactly. And this is not only useful for you, it's useful for us to do some optimization on our platform in the back end. Maybe we have, maybe we get, I'm not sure if you're familiar with the Liferay resiliency framework. Liferay has a resiliency framework where you can configure the system to spawn new back-end processes to offload heavy processing, particularly related to portlets currently. Right? So if you have a really expensive portlet, it's your main business logic, it's getting hammered, and it's the one that's taking 80% of the CPU time. And you want to scale that separately from the portal because the rest of the portal is doing okay, right? So you spawn some back-end processes to do that. Here, we could do the same thing with an arbitrary service. We can use the resolver to say, hey, the permission service of Liferay is under a lot of load. We want to spin it off into a separate process. But I need to run that thing. And I don't want to just split off a whole new Liferay process to do it. I just want to run the service on its own with the requirements necessary to do that. Oh, hey, repository, oh, resolver, resolve me the runtime for that. Drop it into an instance in the back end, offload the request, and I'm done. So it allows us to decompose our system, into smaller reusable services as well, or back-end processes as well.
Just another little question.
Okay.
How easy will it be to migrate a Liferay platform from 6.2 to 7 with all this big architectural changes?
Well, I think that's not a question I can answer right here. Yeah.
No, I have just a little question. What's the second scenario to include native libraries, non-OSGi libraries? You said one is to wrap the library.
in OSGi.
Yeah. The other one?
To actually modify that library to turn it into an OSGi bundle.
Yeah, but the second.
The wrapping is one. Modifying the original is another. Embedding is wrapping, right? We're done. Sorry. We can talk about this after, though.